camera's not working. What's even made you think of that? That's amazing that you thought of that. That would have been such a waste. All right, here we go. So now you took your GCF out, bring it down. Don't forget it as part of your answer, and then treat what's left over as a brand new problem. Try to factor it again. So now, hopefully, this is one of the easier ones. What times what gets you the x squared? X and x, right? We know the fronts have to multiply to the first one. All right, we know whatever number we put here and whatever number we put here have to multiply to who? Negative 18. Excellent. Those are the only numbers you can try. And then we know our inside and our outside rainbow have to add up to who? 3. All right, well, you don't have to do this, but I do think it helps to see your options. We don't have any numbers in front of the x's, so guys, we're literally trying to multiply to negative 18 and add up to 3. Any ones you are leaning towards? 3 and 6. So in any order, it won't matter because they're just x's. Put a 3 and a 6. That's going to get you a 3x. That's going to get you x times 6 is 6x. How do you get them to add up to 3 and then multiply to a negative 18? Positive 6 and negative 3. Amazing. Right, that's definitely going to add up to 3. And then that means this would have to be a minus to get a negative 3x. And this would have to be a plus. So let's make sure everything's doing its job. X times x is x squared. Negative 3 times positive 6 is negative 18. Negative 3x is positive 6. We got our 3. You're golden. All right? I'm telling you, please take that time to check it all. You will catch your own mistake. All right, let's keep going. Let's try it again. Look at this one. If you had to factor this, right? Break it up into pieces that multiply. What do you always look for first? GCF. What does a 3x to the third, a 9x squared, and a 12x have in common? A 3 and an x. Take them both out. So we're going to take a 3 out and an x out. So now your numbers will change, and so will the number of variables. All right, what do we got? 3x times 2 gets you a 3x to the third. Yeah, x squared. 3x times 2 gets you negative 9x squared. Yep. And then 3x times 2 gets you negative 12x. Minus 4. Okay, perfect. All right, now just drop down your GCF. He's going to be part of your answer. And then let's see if we can factor this again into 2 more pieces. All right, what times what gets you x squared? XX. I know whatever numbers I put here have to multiply to who? Negative 4. And then my inside and my outside rainbows have to add up to negative 3x's. So a lot of times people see 4 and they're like, oh, 2 and 2. But what other numbers multiply to 4? 1 and 4. So if you are just x's and you have no number in front to throw off your rainbows, are you going to try 1 and 4 or 2 and 2 first? 1 and 4, I'm trying to get 3. So I'm going to do in any order, 1 and 4. All right, that would get me a 1x and a 4x. How do I make them add up to negative 3 and then multiply to negative 4? Yeah, how are you getting these wrong at home? Haven't got one wrong yet.
No, like, I was getting the right numbers, but it would, like, correct me putting in the different parentheses. Like, I put the same sign.
I'm going to check them. All right, so that means he would have to be plus, and he would have to be minus. All right, so that means x times x got me x squared. 1 times negative 4 got me negative 4. 1x and negative 4x's, we got it. All right, I always like to do one like this because it kind of throws us for a loop when we see it, and it's actually a very nice problem to have in the future. If we had to factor this, number 1, doesn't he look tiny? Right? It's nice. It's nice. It's tiny. It's cute. So when you look at this one and you want to factor it, you're going to break it up into pieces that multiply. You're always going to look for a GCF first. So what does a 4x squared and a 28x have in common? A 4x. So we're going to take the 4x out. Now what would be left? 4x times 2 gets you 4x squared. X, who? X, beautiful. And then 4x times what gets you negative 28x? Negative 7. So now what happens here is, when we were pulling out all the other GCFs, I had a GCF and a quadratic, and I factored again. I had a GCF and a quadratic, and I factored again. I had a GCF and a quadratic, and I factored again. I have a GCF, and does anybody know what degree this expression is? Wait, what? Degree 1, which is linear. Guys, we get linear factors when we're done. So if you get a degree 1 factor after you pull out a GCF, it shouldn't factor again. We're looking to factor quadratics into 2 more pieces. So this should not factor again unless you didn't pull out the biggest GCF. But you should be done once you get down to this linear expression. You cannot factor it again. You just get to be done. This is kind of like Monday's problems, where the only kind of factoring you can do is just take its GCF out and you're done, okay? So always be aware of them, because some students get those ones wrong, and they're meant to be a little bit simpler in the sense that you don't have to go through the whole process again. All right. Now this one I do feel a little bit mean at, because I feel like I've set you up, but it's a really good problem to see for like tips and tricks. We are looking for GCFs all day today. Please don't let me fool you with this one though. Does 3x squared, 13x, and 12 have a greatest common factor? They don't. So this one, again, it's the only one today that we're going to see that doesn't have a GCF, but he's a really good problem to practice because I can show you your tricks with this one. So he doesn't have a GCF, so that just means you have to factor him the way he is. So no GCF, just to make note that we look for it. When there's no GCF, guys, you get to go right to your parentheses. Just go right to creating those factors. All right, we know that whatever you put here and whatever you put here has to multiply to who up here? Front and front get you?
Oh, yes.
Well, just answer my question. Who does this piece and this piece have to multiply to? 3x squared. Okay, so it's not just xx because that wouldn't get you a 3x squared. But lucky for us, what are the only numbers that multiply to 3? So we need a 3x and a 1x. Great. Okay, so that part's set. We know whatever number we put here and whatever number we put here has to multiply to which number up here? We know we got 12. We gotta get 12. So we're only gonna try numbers that multiply to 12. And then we know our inside and outside rainbow have to add up to negative 13x's. Again, give yourself some options. If I'm only allowed to put numbers that multiply to 12, who are they? 1 and 12, 2 and 6, 3 and 4. So yes, it's the guess and check method, but it's not like, hey, guess and check any numbers you want. They have to multiply to the last number, so it narrows your options down. This is my, bless you, this is my tip. Guys, the one thing students will complain about with the guess and check method is they're like, Hardy, that's a lot of guessing and checking. You gotta work the rainbows. I get it, but here's a tip. We will always look for a GCF first. So if there's a greatest common factor, we're going to take it out in the beginning. So if there is no GCF, then none of your factors are allowed to have a GCF. So when you say, all right, Hardy, I guess I'll guess and check 1 and 12 first. If you were to take the time and try 12 here and 1 there, guys, do 3x and 12 have a GCF? Then you're wasting your time. 12 would never be allowed to go there because he has a GCF with the 3. So you would never even waste the time trying him in that spot. So if you want to try 1 and 12, then your only option is to put the 1 here and the 12 there. So it's not like you have to try them both. And now look at your rainbows. What's 1 times x? 1x. 3x times 12x, that's 36 x's. Are 1 and 36 ever going to go to a 13? No. So we know pretty quickly that it ain't 1 and 12. And you're like, all right, okay, Hardy, 2 and 6 are next. If you try the 2 and the 6, guys, would it be worth your time to even try the 6 here? Because they have a GCF. You are not going to create a factor that has a GCF. We take GCFs out in the beginning. So don't even waste your time and try the 6 there. If 2 and 6 are it, it's because 2 goes here and 6 goes there. All right, that's 2x, and that's 18x. Are 2 and 18 going to get you 13? Then it ain't that. So then that only leaves the 3 and the 4. It's got to be that. But if you're going to try it, is it worth it to put the 3 here? Don't put the 3 there. If they're going to work, it's because the 4 goes here and the 3 goes there. Don't make a factor that has a GCF. All right, that's going to get me what? 4x's. That's going to get me 9x. Ooh, how do I get 4x's and 9x's to add up to that negative 13x and then still get these guys to multiply to positive 12? Negative and negative. So that means he would have to be minus and he would have to be minus. So that's a trick that I always use when it comes down to, oh man, this is like a lot of, don't put a number in a factor that would create them having a GCF. You're wasting your time. The only time it could work is if you missed a GCF in the beginning, but we shouldn't because we're always looking for GCFs from the beginning. All right, this is where I'm going to stop on today's notes because I think I repeated problems that we've already done. I don't know if I copy and pasted them and then forgot to erase them, but we're good. Let me just do a couple off of today's notes because I want to show you one other thing about a GCF. And then tomorrow I'm just going to stop and let you guys practice. I won't add anything new tomorrow. Again?
I'm multiple.
No, barely catch it. It's just like, I don't know what's these 28. Miss Hardy.
Yes.
Is that a thing what I did wrong the other night?
What?
Like,
Just the signs were mixed up?
I put it in the wrong parentheses.
Maybe. I'm gonna look at it. I don't know without looking. But maybe. But the order that you write your parentheses doesn't matter as long as what's inside of them
Yeah,
is
that's
correct.
what I mean. Like,
It might be.
well,
You could have been off by the sign.
If they had a GCF and I put it in, it was like the correct pair,
Right.
that would have been wrong.
Right. But I don't think I assigned you any with a GCF yet. So either way, you shouldn't have had. All right. We'll figure it out. All right. But here we go. So guys, continuing on with this whole GCF theme, we're going to factor. We know factoring means break it up into pieces that multiply. I already asked you guys to always look for the GCF first. I just want to show you. If the expression leads with a negative sign, like look at every single problem I gave you today, the number or the piece in front of x squared is negative. If these expressions lead with a negative sign, you're not allowed to factor them with that negative sign. You are always going to factor the negative sign either out with your GCF or as your GCF. So if it starts with a negative and you're like, oh, the GCF is 2, then you're going to factor out a negative 2 instead of a positive 2. You don't want to start this whole rainbow process with a negative x squared. You want the number in front of the square term to be positive. So every time it starts with a negative, you're always going to include the negative sign as part of your GCF. And if you say, well, Hardy, it didn't have a GCF, then you're at least going to factor out that negative sign, that negative 1. All right, so guys, look at this problem. Let's say we had to factor it, right? We have to break it up into pieces that multiply. What does an x squared, a 5x, and a 24 have in common? What's their GCF? 1, right? We would say it doesn't have any. So in that case, you're not allowed to continue though. Even though it doesn't have a GCF, you are at least going to factor out that negative sign. So a math book would say you're going to factor out the negative. In reality, guys, you are factoring out a negative 1. So we're at least going to factor out a negative 1 so that the number in front isn't negative anymore. So if you factor out a negative 1, that means none of the numbers involved will change except their signs, and none of the variables are going to change. So guys, what's a negative 1 times what gets you back to a negative x squared? A positive x squared. It's just going to change their signs. Negative 1 times what gets you back to a negative 5x? Positive 5x. Negative 1 times 2 gets you back to a positive 24. It was positive. So a negative 24, because a negative times a negative will get you back to a positive. Close it. So you are not allowed to start this rainbow process if the front number is negative. So you're always going to factor it out either as the GCF or with your GCF. All right, so now just drop them down. And again, the math book will let you put a negative sign in front. And then you're going to factor this, again, now that it doesn't have a negative number in front of x squared. Or if it makes you feel more comfortable, I did allow you to leave it as negative 1, whichever one you want to write it as, a negative sign or a negative 1. All right, now, what times what multiplies to x squared? X, and X. I know whatever numbers we put here, and whatever number we put here has to multiply to who? Negative 24. And I know my inside and my outside rainbow better add up to 5X. All right? Well, guys, out of all the numbers that you know that multiply to 24, are you feeling any more than the others? 8 and 3. You're trying to get a 5, right? So I'm going to go for the 8 and the 3. So in any order, because it's just X's, so it doesn't matter, 8 and 3. That would get me an 8X from my inside and a 3X from my outside. How do you get them to add up to 5 and then multiply to a negative 24? Positive 8 and negative 3. Awesome. So that means he would have to be plus and he would have to be minus to create those rainbows. So let's see if everything does its job. X times X is X squared. 8 times negative 3 is negative 24. Positive 8X, negative 3X, there it is. And then just don't forget, when you type your answer in, you either have to have a negative 1 out in front or just a negative sign. But you have to have that sign. And that's it. So when you see it lead with a negative, always take the negative out at least as your GCF. If not, add it to the GCF. All right, let's look at, how much time do I have? I have it. If you look at this problem, who's your GCF between 2x squared, 3x, and 14? They don't have one, but because it leads with a negative, you're definitely going to factor out at least a negative 1 or a negative sign, however you want to think of it. So we're going to take out the negative 1 or the negative, and then show me what's left. Negative 1 times 2 gets you back to negative 2x squared. 2x squared, it just should change their sign, right? Negative 1 times 2 gets you back to positive 3x. Negative 3x, and then negative 1 times 2 gets you back to a positive 14. Negative 14. All right, now we're back in business. So drop your GCF down. And again, I don't care if you drop down negative 1 or just the negative sign. It's a personal preference. And then let's see if we can factor it again. And now we're allowed to because it doesn't have a negative number in front. You do not want to do those rainbows by saying negative 2x, positive 1x. You don't want that. All right. We know whatever we put here and whatever we put here has to multiply to the front, 2x squared. What are the only numbers that multiply to 2? 2x and 1x. Done. We know whatever numbers we put here and here have to multiply to who? Negative 14. And then we know our inside and our outside rainbows have to add up to those negative 3x's. Okay, options. There aren't a lot. Anybody care who we try first? Because that 2 is going to kind of throw off some of our rainbows. I would probably say pick your more popular factors of 14. So I would probably say 2 and 7 come to your mind before 1 and 14. So I'm probably going to try 2 and 7 first. It could be 1 and 14, though. It's just a matter of the guessing game. But if I do try 2 and 7, who am I definitely not trying here? 2. Don't waste your time. It ain't going to go there. They have a GCF. So try 7, try 2. So 7 times... Yeah.
So it doesn't matter, because X still goes to 2 for the second one, so it only matters about the first one?
No, they don't have a GCF. This is a 1 and a 2. They don't have a GCF. 1x and 2 have no GCF.
Oh, because 1 doesn't, okay.
Oh, wait, so they don't have a GCF because 2, 7, and x have nothing in common. They don't have a GCF because x and 2 have nothing in common.
Oh, yeah.
Am I saying that right? Yeah.
Is it possible to both happen?
No, it wouldn't. The only way it would happen, Stephen, if you factor it and you're like, Hardy, I put the 2 here and the 7 there and it worked. The only way you would ever end up with a factor that had GCFs in it is because you missed the GCF in the beginning. And we should never miss a GCF in the beginning, Stephen. So that's why we can safely say there would never be a GCF down here. But if you did miss it in the beginning, then yes, but we're never going to miss it in the beginning. Okay, good questions. All right, so we know it's got to be 7 and 2. So 7x, 4x. Ooh, how are you getting 7x and 4x? We would not even have to try those ever. How do 7x and 4x go to negative 3? Negative 7, positive 4. That's part of the game. We would have fixed that. And then they'll still be able to multiply to a negative 14. So this would have to be minus, and this would have to be plus. Let's double check. 2x times 1x is 2x squared. Negative 7 times positive 2 is negative 14. And then negative 7 and positive 4x get me my negative 3x's. We did it. All right. I know I've thrown a lot at you. The only thing I want you guys to do, and I won't let you finish it, just tell me who this GCF is in the next problem. 2, but because it leads with a negative, you're going to factor out a -2. That's what I mean. So if it does have a GCF, just make your GCF a negative GCF. So you would pull out a -2, and then it would leave you with a positive 3x squared, yes? A -2 times who gets you a positive x? Negative. It can't be -2x, because that would be positive 4. Just negative, yes. And then -2 times what gets you positive 4? -4. And then you would start factoring again. Okay? But that's the point of today. I need you looking for that GCF right out of the gate, taking it out, and then factoring what is left. And then always, if it starts with a negative, you are at the very least going to factor out a -1. Okay? All right. So I gave you guys a homework assignment tonight on quizzes. It is 7 questions long. Every single problem tonight has a GCF, whether it's a -1 or whether it's a 2x or a 3x or a -2, but everything has a GCF. It's not due until tomorrow night. And then today, last night's homework is due tonight on Delta Math. And then tomorrow, I am going to pause for a day and just let you practice a few in class before I show you the last one. Okay? Yes.
So you bring down the -1. It
Yes.
has nothing to do with on the inside, right?
It has nothing to do with this, what we're factoring again. It's only there because at the end of the day, we need these to multiply back to the original. So without him, they never go back to the original. But you only need these to multiply to this. Okay? Yeah, Shabbat. Absolutely. I can sign your pass or I can write you one. I don't know which one you need. All right.
Oh my God.